Hi class, Dr. Bevilacqua here. I wanted to go through an overview of the equations that we use in error propagation. Let's begin by considering addition, y equals a plus b, and then after we finish that, we'll go through multiplication, y equals a times b. The equations that we use for addition is that the error in y, which we'll denote as sigma sub y, the square of that is equal to the square of the error in a plus the square of the error in b. We can then solve for the error in y as plus or minus the square root of the right-hand side, and that makes sense because error can be both positive and negative. And the final answer we can represent as y equals plus or minus the error in y. Also want to point out that this works equally well for subtraction because we can think of subtraction as y equals a plus minus b, which is equivalent to addition. Let's move over now and think about what happens with multiplication. The math is similar, except now instead of simply using the error in y, we use the relative error in y, or the percent error in y, and we square that. And we have similar terms on the right-hand side for both a and b. We can similarly solve this equation by taking the square root of both sides. This gives us the relative error in y. We can then go ahead and get the absolute error in y by taking the y term and multiplying it over. I'd also like to point out that the final answer here, similar to on the left-hand side, is equal to y plus or minus the error in y, and that this type of math works equally well for division, since we can think of division in which we have a divided by b as multiplication of a times 1 over b. Before moving on, I'd also like to say a word about units. So we know that when we add two numbers together, they have to have the same units. Let's say milliliters. And that works in the errors, since if a is in milliliters, then this term is milliliters squared. B is in milliliters, so this term is milliliters squared. We add them together to give milliliters squared. We take the square root, and we end up with milliliters, just as expected. However, if we consider over here, let's take division. Let's say this is density, and this is mass per volume. Then the relative error is error in mass over mass, or it's unitless, and we square that. Likewise, this would be error in volume, let's say milliliters, and milliliters over milliliters is unitless. We square that. We can add together two unitless terms, and the answer should be unitless, and in fact it is, because this is units of density over density. And in the end, we can get out the absolute error in units of density because we have units of density multiplied by a unitless term. Often when I get stuck, I think in terms of units, and we can see over here that there's no way we could use the same formula that we did for addition for multiplication, because otherwise we'd be adding together two terms that had different units. I thought it would be useful to now go ahead and consider the relative values of the two terms that go into the error. And when we look at this equation, it looks like the Pythagorean theorem, which is, as we know, applies to a right triangle. So we can consider the error in y as being along the hypotenuse, and the error in a and the error in b as being along the two edges. And we can consider two cases, one in which the two edges are equal in length, or the error in a is equal to the error in b, and one in which one of the errors is much larger than the other. In the first case, we can see by applying this math that the error in y will be equal to the square root of 2 times the error in a, or 1.4 times the error in a. However, over in this case, we can see that the error in y will be approximately equal to the error in b, which is what we expect since this term has much larger error. The last thing I'd like to do is point out that the math that I showed you on the previous slide is not limited to simply having two terms. So for example, we can have three terms. In this case, this would formally apply to a cube, and because we're using addition, it would now be that the error in y squared is equal to the sum of the square of the error in each of the three terms. But we could also have 4 terms or 5 terms in which it becomes so abstract there's no direct analogy, but we would simply take and add on the 4th term and the 5th term and solve for the error in y. Thanks for listening.